This is section 3.10, and it is on related rates. And related rates have to do with trying to find the rates of change of two or more related variables that are changing with respect to time. So no longer do we have just a dy dx, but every variable will have a dt. So example, if you are talking about the velocity of a car after traveling for 1 hour, so x is the distance traveled, and the velocity is 50 miles an hour, then that means dx dt is 50 when t is 1. So everything has a dt. Water is being pumped into a swimming pool. So V is the volume of the pool, water in the pool, at a rate of 10 cubic meters per hour. So dV dt equals 10 meters cubed per hour. So just remember, everything will have a dt. Now here's some strategies that I think will be helpful. Draw a picture and name the variables and constants if it warrants drawing a picture. Use T for time. Write down the numerical information. If you know something is 50 miles per hour, write that down. Write down what you are asked to find, usually a rate. Then you'll write an equation that relates the variables. You'll see what that means when we look at our problems. Differentiate then with implicit differentiation with respect to t. So you'll differentiate every term with respect to t. So if it's an x term, you'll have a dx dt attached. If it's a y, it'll be a dy dt. If it's the area, it might be dA dt. So that's how that will go. And then you'll evaluate to find the unknown rate. So that's really the notes for this. Let's go look at our problem set. All right, number 1, suppose that a dimension x and the area A equals 12x squared of a shape are differentiable functions of time. Write an equation that relates dA dt to dx dt. So here's what we need to start with. We write the equation we're given. A is equal to 12x squared. And then if we differentiate both of these, when you do it to A, you get dA dt. And when you do this, you get 2 times 12 is 24x dx dt. So the 24x is what is expected in this box. This is just starting out slow. All right, number 2. Assume that x equals x of t and y is y of t. Let y equal x squared plus 2. dx dt is 5 when x is 2. Find dy dt when x is 2. So we start with the equation given, y equals x squared plus 2. We're going to differentiate that all across the line. So we have dy dt equals 2x dx dt plus 0. Now at this point, they gave you what dx dt was, and they gave you what x was. So we can plug in for those two pieces, and we get that dy dt is 20. So that's how we'll do that one. All right, number 3, assume that all variables are implicit functions of time t. Find the indicated rate. So here is the function, and we're supposed to find dy dt. So we'll go through and do all our differentiation. This is 2x dx dt. This is 8y dy dt plus 2 dy dt, because you just get a 2, the y is gone, equals the derivative of 12 is 0. So once you get all of that and you've got these to plug in, you're going to plug in 3 for dx dt and 3 for x, and y is negative 1. So when we fill that out, we've got now 18 minus 8 dy dt plus 2 dy dt equals 0. We want these together. So this is negative 6 dy dt. Subtract the 18. Now divide negative 6 into negative 18. You get dy dt is 3. So often you're given an equation, or you create your equation, and you do the differentiation, and you're going to plug in what you do know to solve for what you're asked to find. Number 4, a metal cube dissolves in acid such that an edge of the cube decreases by 0.4 millimeters per minute. How fast is the volume of the cube changing when the edge is 7.9 millimeters? So, drew my nice little cube, which is so badly drawn. You're given that the edge is decreasing at 40.40 millimeters per minute. So ds, if s is the side, ds dt is negative 0.40 because that's a rate. You're supposed to find the volume rate change. So find dv dt when s is 7.90 because the sides are changing as it's melting. We need to know the volume of a cube formula, and that's when they're all the same side, it's just s cubed. So here's our formula that we're going to differentiate. So dv dt on the left equals 3s squared ds dt. Now we're trying to find dv dt. So this is our unknown. We know that we're finding it when ds dt is negative 0.40 and when the s is 7.90. So we're going to do this calculation in our calculator, square that, multiply it by negative 0.4 and by 3. You get negative 74.89. It says round to the nearest integer. Be sure you read the directions as to how you're supposed to round. It is negative 75 because the volume is decreasing. All right, let's look at number 5. All right, the dimensions x and y of an object are related to its volume v by the formula v equals 3x squared y. So here's this. And then it asks you to really have to think here about what if x is a constant, what if y is a constant, what if neither of them are constants. Remembering that a constant, you know, that doesn't affect anything, doesn't have a dx or a dy, it's just a number. All right, so I wrote here what dv dt would be. It would be 3x squared times the derivative of this one, which was dy dt, plus y times the derivative of this one, which is 6x dx dt. But if we're thinking about dv dt and x is a constant, x is a constant, so that means all of this is a number, right? And so this would be 3x squared dy dt. That's what that is, because this is just the number. If it were v equals 6y, it would be 6 dy dt. And so they're saying that's a number. Now, if y is a constant, that's a number. So you've got 2 times 3 is 6x, and you're multiplying by the other constant that you've got, which is y. So 6xy dx dt. If they're neither one are constant, you do have what we got here. You've got 6x dx dt plus 3x squared dy dt. So this is normal. This was making you think about if x was constant and if y was constant. All right, let's move to number 6. All right, when a circular plate of metal is heated in an oven, its radius increases at a rate of 0.04 centimeters per minute. At what rate is the plate's area increasing when the radius is 46 centimeters? So this is expanding in the oven, all right? The rate of change of the area, all right, but we're given that the radius is changing. So dr dt is 0.04 centimeters per minute. We're supposed to find how the area is changing. So find dA dt when the radius is 46. Well, the formula that relates all this is the area of a circle. So A is pi r squared. We start with that. Then we're going to differentiate both sides. dA dt is 2 pi r dr dt, because 2 times pi r dr dt. And then we can plug in, we know that dr dt is 0.04. We know that r is 46 when we want to check it. We multiply, and this says leave everything in terms of pi. So you multiply all your numbers, and it's 3.68 pi centimeters squared per minute. All right, let's look at number 7. This is a long question. It has 3 parts. It's an important question. 13-foot ladder is leaning against a house. So here's your ladder. When its base starts to slide away, by the time the base is 12 feet from the house, the base is moving away at a rate of 10 feet per second. So they want to know the rate of change of the height. How fast is this changing at the top of the ladder? At what rate is the area of this triangle changing? And at what rate is the angle between the ladder and the ground changing? So if you think of this as a right triangle, and this is 12, the ladder was 13, we don't know why that value, but we can find it with the Pythagorean theory. So 12 squared plus y squared equals 13 squared. We solve down and we get y is 5. So now we have this triangle, 5, 12, 13, theta is here. Let's look at A part, at the rate of change of the height of the top of the ladder. So that's here. Given dx dt is 10, because this piece is changing, it's sliding, and so it's at 10 feet per second. We're supposed to find dy dt. How fast is this coming down? So what relates those? X squared plus y squared equals 13 squared. We're not going to use these numbers yet. So 2x, if we differentiate, 2x dx dt plus 2y dy dt equals 0. Then we can plug in 12 for x, 10 for dx dt, y is going to be 5, we have 2, we don't know dy dt, that's what we're trying to find, equals 0. So multiply here, you get 240, you got 10 dy dt, subtract the 240 and divide by 10 and you get negative 24. That should make sense because it's sliding down, all right? That's the rate that it's decreasing. All right, so that is that piece. Now, the area is changing at what rate? So the area of a triangle is 1/2 base times height. So we have A is 1/2 x, y. dA dt, that's the derivative of that, equals 1/2. Now we have a product, x times dy dt plus y times dx dt. At this point, we can plug in what we have. dA dt is 1/2, x is 12, dy dt is negative 24, we found that, plus y is 5, dx dt is 10. So you get this number and then you take half of it, you're going to get negative 119 is dA dt. All right, last part. The angle is changing at how many or what rate radians per second. So I think the easiest way is to think about, here's theta, here's cosine. I mean, here is 12. But the cosine of theta is equal to x over the ladder, adjacent over hypotenuse. That's from trig. So cosine theta equals x over L. I'm just going to call L the ladder. If you take the derivative, you've got negative sine theta d theta dt equals, that's just a 1, so that's 1 over L dx dt. At this point, we can plug in. We have negative sine theta. So if we're here, sine theta is 5 over 13. So we have negative 5/13 d theta dt equals 1 over the latter, which was 13, times dx dt, which was 10. And then we have 10 over 13. We're going to divide by this, which means we multiply by its reciprocal. And the 13s cancel out, negative 5 goes into 10, negative 2 radians per second. And that would be the answer for that one. So, important question, could be a test question. It incorporates a lot of different things. It's one worth studying and understanding. The last one, because number 9 is omitted from the actual homework. A spherical balloon is inflating with helium at a rate of 144 pi feet cubes per minute. How fast is the balloon's radius increasing at the instant that the radius is 3 feet? And how fast is the surface area increasing? So I took the opportunity to be really creative and draw this cute balloon. But this is a spherical balloon and it's inflating. So that means its volume is increasing. And so dV dt is the 144 pi. And we're given that at the instant we're talking about, r will be 3. So we're supposed to find dr dt when r is 3. The formula for the volume of a sphere is 4/3 pi r cubed. So we've got dV dt equals 4. So 3 times 4/3 is 4 pi r squared dr dt. We'll plug in r here, and then we'll divide. So we have 9 times 4 is 36. So we'll divide the 36 pi into 144 pi. 4 is dr dt. So that's what's going there. 4 feet per minute, the radius is increasing. And then the formula for surface area is 4 pi r squared. If we take the derivative, we got ds dt equals 2 times 4, 8 pi r dr dt. We're going to put in, we found dr dt, so that goes, 4 goes there, 3 is your radius, multiply all of those, and so ds dt is 96 pi. That is what goes there. So that's a sampling, and we are omitting number 9. That's a sampling of related rates, and so that's important. Try to go over those, and hopefully that will be good.